Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss molecular mass of polymers. Last class I have discussed many things, means copolymerization. Under that I have discussed 1,3-butadiene styrene copolymer. Also I discussed natural rubber, vulcanization of rubber, synthetic rubber. Under that I have discussed neoprene. Now also I have discussed Buna N also, neoprene and Buna N under synthetic rubbers. Now I am going to give idea about molecular mass of polymers, and also I will discuss biodegradable polymers. Polymer properties are closely related to their molecular mass, size and structure. Polymer properties are closely related to their molecular mass, size and structure. The growth of the polymer chain during their synthesis is dependent upon the availability of the monomers in the reaction mixture. Thus, the polymer sample contains chains of varying length, and hence its molecular mass is always expressed as an average. You can't tell exact. Okay, molecular mass is always expressed as an average. The molecular mass of polymers can be determined by chemical and physical method. Now I want to tell about biodegradable polymers. A large number of polymers are quite resistant to environmental degradation processes and thus responsible for the accumulation of polymeric solid-based materials. A large number of polymers are quite resistant to environmental degradation processes and are thus responsible for the accumulation of polymeric solid waste materials. These solid waste are cause acute environmental problem and remain undegradable for quite a long time. In view of the general awareness and concern for the problems created by the polymeric solid waste, certain new biodegradable synthetic polymers have been designated, or you can tell designed. This in view of general awareness and concern for the problems created by the polymeric solid waste, certain new biodegradable synthetic polymers have been designed and developed. These polymers contain functional groups similar to the functional groups present in the biopolymers. Aliphatic polyester are one of the important classes of biodegradable polymers. You remember, aliphatic polyesters. Aliphatic polyesters are one of the important classes of biodegradable polymers. Some important examples I will discuss. First, I will discuss PHBV. P, capital P, capital H, B, capital B, capital B. PHBV. poly beta hydroxy butyrate, co beta hydroxy valerate. This is the full form of PHBV. P means poly beta hydroxy butyrate, co beta hydroxy valerate. Then here P means poly beta hydroxy butyrate. Okay. And after that BV is there, then that means co beta hydroxy valerate. Shortcut PHBV. Again one more time I am telling you, poly beta hydroxy, both are beta. Poly beta hydroxy butyrate. Hydroxy, P means poly, beta hydroxy butyrate. Then that is means H, hydroxy butyrate. Hydroxy butyrate. Hydroxy butyrate means PHB. And last V is there. That is the co-beta hydroxy valerate. Valerate. You remember this question is asked. PHBV. Poly beta hydroxy butyrate. That is for PH. PHB. Poly beta hydroxy butyrate. PHB. And for the last B, it is a co-beta hydroxy valerate. It is obtained by the copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. Both are acid. One is 3-hydroxybutanoic acid, another is 3-hydroxypentanoic acid. Means one is butanoic acid, another is pentanoic acid. Correct? Then first one is 3-hydroxy means carbon number 3, OH will be there. It is a butanoic acid. And next pentanoic acid, carbon 3rd hydroxy group will be there, OH. Correct? Then these PHBV is the copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. PHBV is used in specialty packaging, orthopedic devices, and in controlled release of drugs. Where it is used? Then it is used in specialty packaging, orthopedic devices. First, it is used in specialty packaging. Second, orthopedic devices. And third, in controlled release of drugs. 3 places it is used. First, in specialty packaging. Second, in orthopedic devices. And third, in controlled release of drugs. PHBV undergoes bacterial degradation in the environment. If we will throw it in the environment, then it will go degradation. Who will degrade? Then bacteria will degrade. That's why PHBV undergoes bacterial degradation in the environment. Now reaction I am telling you, CH3 CHOH, CH2 COOH. This is the 3-hydroxybutanoic acid. Means here total 4 carbons are there. First is CH3. This CH3 is joined with next C, and that C is joined with third CH2, and last, that is the COOH. Total 4 carbon. Then here from the carboxylic group, that carbon is first, next is CH2, second, third one is CH. From that third carbon OH is attached. After that, in the end, CH3 is there. Okay, you can write CH3 CHOH. With second carbon, OH is there. But from the COOH side, it is the third carbon. Correct? And this CH3 CHOH, after that CH2, and in the end COOH. This is a 3-hydroxybutanoic acid. Like that way, another you will use pentanoic acid, same way. Here, total 5 carbon will be there, including COOH. And that one carbon is there. Then here again, carbon number third, OH will be there. And always you have to maintain tetravalency of carbon by adjusting hydrogen. Means now 3-hydroxypentanoic acid, you can write CH3 CH2 CH. With this C, OH is attached. After that CH2, that is the fourth one, and final one is COOH. Then reaction is very easy. Both will come close. 3-hydroxybutanoic acid and 3-hydroxypentanoic acid, both will come close. But here, that is butanoic acid, COOH is there. That side, CH3 of 3-hydroxypentanoic acid will come. Means OH of butanoic acid and H of pentanoic acid, both will form water. Both will form water, OH and H. OH, when OH will go as OH minus, then carbon will become positive, because this COOH always one oxygen is attached with carbon with double bond, and OH is attached with the carbon with single bond. And this OH bond will break C and OH. OH will go as OH negative, carbon will become positive. And here, second, this pentanoic acid, CH3 is there. From that, H will go as H plus. Then carbon will become negative. Then negative carbon and positive carbon both will join. Correct? Negative carbon, when H will go as H plus from the pentanoic acid, then now it will be CH2 and carbon will be negative. That carbon will join with positive carbon from where OH has gone. Then now you got the product. H2O will go outside. Means now we will get a long chain. Correct? CH3, but both side hand will be open, means one valency will be there. Because CH3 was there in the butanoic acid in the beginning, that will be CH2. That will be CH2. Correct? And after this making a long product, molecule will be long. Then also that last will be one valency will be there for the further linkage. Means you will get that in bracket you will write, or you can write that OCH, CH3, CH2, all things are as it is. Nothing you have done. Just here only you have to think that bonding can take place. Bonding can takes place wherever OH is there. You remember, wherever OH is there, bonding can take from that side. Means from carboxylic group also that side, and OH is there, that side also it is possible. Then now here OH and H will join, OH and H will join as H2O, and carbon negative, carbon positive, both will join to each other and bond is formed. And that molecule, that is the, you will get OCH, with that CH3 will be there, again CH2, again COO, means where it is joined only there it has changed. OH and H only, that is the only difference. All things are as it is. Correct? All things are as it is. And you remember, whenever OH will go, then only CO will remain. Only CO will remain. Correct? Then you will get PHBV, means O, CH, CH3, CH2, C double O, again O is there. With that O, CH has joined, again CH2, CH3, and again C double O is remaining. C double O, whole N, this is the repeating unit, whole N. You will understand it only when you will see the structure. Okay, I will try to send the structure. Okay, product PHBV. Then this I have told you about the PHBV, polybeta hydroxy butyrate, co-beta hydroxy valerate. Okay, this I have discussed. Now next I am telling you about the new nylon you can say polymer, that is a nylon 2, nylon 6. You have seen nylon 6, 6,6. You have seen only nylon 6 also. Now third things I am discussing you, nylon 2, nylon 6. It is an alternating polyamide copolymer of glycine. Glycine means NH2, CH2, COOH. Correct? This is the glycine, means amino acid. CH2, NH2 is joined with CH2 and CH2 is joined with COOH. Okay. Then nylon 2 and nylon 6. It is an alternating polyamide copolymer of glycine and aminocaproic acid. What is the formula for caproic acid? One you can say molecule is glycine, that is the NH2, CH2, COOH. This will join with aminocaproic acid. Its formula is NH2. Then it is long, CH2, 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 CH2 5 times. And that's why you can write NH2, CH2 whole 5. 5 times you have to write CH2. Okay, attached to itself. Then NH2 is attached with the CH2 whole 5. And in the end, COOH is there. Correct? Both molecule, glycine and aminocaproic acid, both have COOH and the end. And what is the new about this nylon 2 and nylon 6? What is the special quality? Then it is a biodegradable. Okay, and its a structure, this is also biodegradable, and its a structure you can write very easily. Both you will write glycine and aminocaproic acid, both formula you write close to each other, and then you know what will happen, that from glycine OH, and from the caproic acid, aminocaproic acid, NH2 is there in the beginning, from that H will go as H plus, then N will become negative, and this side, glycine side, OH will go, then carbon will come positive, then like previous reaction, it will join, and H2O will go as a additional product. Okay, then now this unit will repeat. That's why you can write in bracket and outside write N, a small n, and whenever you are writing any polymer, then both ends should be opened, means one valency will be there to make bond for others. All things you can write in bracket. Then now I have discussed about the nylon 2, nylon 6. Then 2 I have discussed biodegradable, you can say polymer. First I have discussed, that was PHBV. Question is asked because it is limited. It is a limited. Nowadays, whatever you are getting in a mall, they are taking 3 rupees, 4 rupees according to the size, and they are giving you cover. That is made up of valerate only, PHBV. And also, sometimes they will give this nylon 2, nylon 6, biodegradable. Okay, it can, after throwing it into here and there, then it will be degraded by bacteria present in the, I can say, land. Now I am telling you some commercial importance of polymers. Polymers of commercial importance. Okay, this is also question is asked. What are the polymers of commercial importance? Now I am telling you few polymers I will discuss. Besides the polymers what I have discussed, some other commercially important polymers along with their structure and usage I will tell you. Then first I want to tell you polypropene. Then what is the monomer here? Propene. N number of propene. Correct? Monomer will be propene. When it is joined n times, repeating n times, then it will be called polypropene. Means a structure is a structure which will repeated unit, that is the CH2, CH, CH3, and CH3 as the branch. Then now 2 carbon is there, third one is the as a branch, CH3. Then both carbon is have one valency opened. Then CH to CH, with that CH3 is attached. All things you can write in bracket, and outside the bracket down you can write a small n. Okay, this is the structure. And what is its use? Then uses I am telling you: manufacture of ropes, toys, pipes, fibers, etc. Its use is in manufacture of ropes, toys, pipes, fibers, etc. Second is polystyrene. It's a repeating unit is styrene, means monomer is styrene, and its structure is again what I discussed. Polypropene, same way, in the place of methyl group, now phenyl group will be attached. All things will be as it is. This is the repeating unit. You can write this structure, means CH to CH, and with this CH, C6H5 is attached. Whole things you can write in bracket, outside a small n. Where it is used? Then as insulator, wrapping material, manufacture of toys, radio, and television cabinets. You have seen television cabinet is there. You might have seen that is always there will be some plastic like material. That is actually this polystyrene. Then polystyrene is used as an insulator, wrapping material, manufacture of toys, radio, and television cabinets. Next is PVC, already I have discussed, polyvinyl chloride. Then here repeating unit is vinyl chloride, that is called monomer. Monomer is vinyl chloride. And now it is again what I discussed now too, same way its structure is there. Here in the methyl group, second time you have written phenyl group. Now in the place of these groups, correct? First case it was methyl. Second case means in polystyrene, phenyl group was there. Now here Cl group will be there. With the C, Cl will be attached. In the first case, with the C, CH3 was attached. In second case, polystyrene, C6H5 was attached with C, with second carbon. And here Cl will be attached. Cl. Many times I have discussed PVC. Then where it is used? Then it is used in the manufacture of raincoats. You might have seen in rainy season people will wear raincoats. Then that is actually made up of PVC, vinyl chloride, polyvinyl chloride. Second is handbag. Handbag you are using. In market they will give the cover handbag. Okay, different type of bags are there. This is a strong bag. A strong, you can say, handbags. Vinyl flooring. There it is used. Water pipe. Water pipe also, in water pipe it is used. Okay, hand pipe, inside they were, after the drilling they are putting this pipe only, PVC. Actually here it is used mostly everywhere, that pipes, water pipes. Now next is urea formaldehyde resin. Urea formaldehyde resin. Here two types of monomers you will use. It is a copolymer. First is urea, second is formaldehyde. Already I have discussed. Urea plus formaldehyde. Okay, these are the monomers. Urea and second is formaldehyde. And here what is the structure? Means repeating unit, what will be there? Then NHCO, NHCH2. Total 4. NH first, second is a CO, third is again NH, fourth is CH2. And both end, first and last end, 1 balance is there. Correct? This is the repeating unit that you can write inside the bracket and outside N, small n. Okay. This is actually resin. Resin is called urea formaldehyde resin, where it is used for making unbreakable cups. See the importance. Unbreakable, many items are there, unbreakable. Then for making unbreakable cups and laminated sheets. Lamination you are doing. Then material is required. On the paper some material they will put. That material is resin, urea formaldehyde resin. Then this resin, urea formaldehyde resin, is used for making unbreakable cups and laminated sheets. Now next I am telling you, this is unknown, glyptal, 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 glyptal. Here again it is the copolymerization process is involved. Then two different monomers are used. First is ethylene glycol. Second is phthalic acid. Phthalic acid, know that in benzene, COOH, 2 COOH will be there in phthalic acid. Then ethylene glycol plus phthalic acid. Reaction will be easy. Okay, and then here you will get a product, a structure. I am telling about repeating a structure, because ethylene glycol you have used. The ethylene glycol is dihydric alcohol, CH2OH, CH2OH. Correct? And phthalic acid already told you, in benzene ring 2 COOH group is attached to. Then this COOH will involve in bond formation. OH from the ethylene glycol. OH from ethylene glycol and COOH from phthalic acid. Then one will H, other will lose one. If phenol will lose OH, then C double OH will lose H, and both can join, and H2O will go outside. Okay. Then this is the unit OCS2, and always I told you last will be the open hand. 1 valency will be opened for further joining. Then you can write OCS2 CS2 double OC, benzene ring is there, and then again other C double OH was there, but you have to write open end because OH will lose finally in the end, then only CO will remain. Then where this glyptal is used, use of glyptal, then in the manufacture of paints and lacquers. Okay, in the manufacture of paints and lacquers. LACQUERS, lacquers. Now last is a bakelite. Already I have discussed in details about bakelite. Here monomers, 2 monomers I will use. It is also here copolymerization will take place. Then both monomer will be different here. One is phenol, other is formaldehyde, and this repeating unit means a structure which will be repeated. That is phenol, you know that CS2OH is there, that is the phenol, correct? And formaldehyde is HCHO. Formaldehyde is HCHO, correct? Then here phenol and formaldehyde will repeat. Okay, means here in this structure, one phenol and one phenol and one formaldehyde will take first. Then you know that what will happen, because phenol is HCHO. HCHO. Then here oxygen is there, OH is there, and H from the benzene. Means O will go from the CS2OH. O will go. Then it will join with the phenol. Okay, from the phenol, each carbon H is there. That from that H will. Now O will be there. Actually, 2 phenol will come. 2 phenol will come. Correct? I told you between the 2 phenol unit, CH2 will come. Correct? CH2OH, that is, or you can say not CH2OH, HCHO, you can write CH2O. Then to remove one O, 2 H is required. Then from the 2 phenol unit, HH will come out and it will react with oxygen. Then it will go as a H2O, and it will join, both ring will join, and in the middle CH2 will be there. Then it will continue. Then repeating unit structure I am telling you, that is a benzene, with benzene 1 OH is already there. After that CH2 is there. With this CH2 another benzene ring is there, means phenol is there. With that again it will repeat, CH2 will be there. Then again here both end 1 valency will be there, opened for further repetition. Outside whole N you can write. This is the bakelite. Last class only I have discussed. Okay, where it is used? It is used for making combs, electrical switches, handles of utensils, and computer discs. Computer discs also, in that this material is bakelite is used. Wherever hardness is required, hard material, there it is used. As for example, comb you have seen, it is hard. Electrical switch you have seen, this is hard. Handles of utensils in kitchen you have seen, that is also hard. And computer discs, that is also hard. And now I have finished this chapter also, polymers chapter. Now last chapter is remaining of your 12th, that is the chemistry in everyday life. I will discuss in the next class. Thank you.